Before I start this video, I want to ask you to support me by subscribing to my channel. And please like this video if you find it helpful. And of course, if you have some questions or suggestions, welcome to the comments. And we jump right in.
Hi everyone! In the last video, we built an email sending microservice using a service-oriented architecture. Service-oriented architecture, or SOA, is a way of designing and organizing information systems that breaks application and components down into small independent services. But what's the problem we are facing right now? Right now, we are calling the microservice directly in the controller, which means we can't reuse it in other parts of the app. That's because the controller can change the state of the microservice. For example, the controller can call a method of the microservice that saves data to the database. If we try to reuse the microservice in another part of the app, we won't be able to access that data. To reuse a microservice in another part of the app, we should use the publish-subscribe pattern. In this case, the microservice will publish event, and subscribers will handle that event. Let's take a closer look at this pattern. The publisher-subscriber pattern is a behavioral design pattern that decouples publishers from subscribers. A publisher simply publishes events, and subscribers register for events that they want to receive. This pattern is useful when you want different components of an application to be able to exchange information without knowing about each other. In the publisher-subscriber pattern, there are the following participants. Publisher. The publisher is the component that generates events. It is responsible for publishing events to the event bus. Subscriber. The subscriber is a component that receives events. It is responsible for registering for events that it wants to receive and then handling those events when they are received. Event. An event is a message that is published by the publisher. It typically contains information about an event that has occurred. Event bus. The event bus is a mediator between the publisher and the subscriber. It receives events from the publisher and delivers them to the subscribers. The event bus can be used to decouple publishers and subscribers and to make it easy to add or remove subscribers without affecting the publishers. In my microservice, the logic for sending emails is in the controller. This violates the publisher-subscriber pattern, as the controller is both a publisher and a subscriber. In the publisher-subscriber pattern, the publisher simply publishes events and subscribers register for the events they want to receive. In this case, the dependency inversion principle is violated. The dependency inversion principle states that classes should depend on abstractions, not on concrete classes. In this case, the controller depends on the concrete class feedback service, which is responsible for sending emails. We will implement the publisher-subscriber pattern using the Symfony component called Messenger. I will show you how it will work in an infographic, and then we will implement it in the code. So, the controller is a mediator between the user and the application. It receives a request from the user, sends a message through Messenger. This message is processed by the handler, which directly sends the email. Then the controller returns a response to the user. But still, before we start refactoring our code, we must consider one more pattern in the context of DDD, namely command. Command pattern is a design technique that helps organize and manage actions or tasks in a way that makes them easier to control. Imagine you have a list of tasks you want to do, but you don't want to do them right away. Instead, you want to write them down, so you can do them later when it's more convenient. This is similar to what the command pattern does. It writes down your tasks or commands and lets you do them when you are ready. In the context of DDD, which is a way of designing software to closely match real-world concepts, the command pattern is used to represent actions or requests related to a specific part of a business. Think of a domain as an area of expertise that deals with a particular job or topic, like a finance domain for a bank. In DDD, we want to describe how things work in that domain, both in terms of the data involved and what actions can be performed. The command pattern in DDD helps separate these actions, or commands, from the actual code that does the work. This is handy because it means the way you perform an action can change without affecting the command itself. It makes the commands more independent and flexible. And first, let's install the Messenger bundle. Now let's create a class called createFeedbackEmailCommand, which will represent a command to send feedback. This class should contain all the necessary data to send feedback, such as form data. Now let's create a class called createFeedbackEmailCommandHandler, which will handle the command and directly send the email. We will not send a confirmation email to the user in this handler, because it is better to separate different actions between different commands and their handlers. Such as in our case, sending the main email and sending the confirmation email. This makes the code cleaner, more modular, and adheres to the single responsibility principle. Now the factory needs to be updated so that it can create a feedback email object, not from a request but from a create feedback email command object. Now, by analogy with what we did with you earlier, we will create a command and a command handler to send a confirmation email to the user in response to an email sent to us by the user. So, the controller takes data from the request, creates a feedback email command, and sends it using message bus interface. If this command is successful, the controller also sends a confirmation email command and returns a message about successful sending. In case of sending error, it returns an error message. Let's check if everything is working correctly and if the emails are being sent. For now, our application behaves as expected. So we did not configure the transport, and by default messages are processed synchronously. This means that the message handler will wait for the task to complete before continuing to process the next message. In order for messages to be processed asynchronously, a transport must be configured. But we will do this a little later. And now we need to add validation of incoming data. So we will use the validator component, and first we need to install it. And now in the command we need to define asserts for incoming data. This will help to ensure that the data is valid and can be processed by the application without any errors. So, not blank assert ensures that a field is not empty. Length assert defines a valid range for the length of the text in a field. Regex assert checks that the text in a field matches a regular expression. In this case, it allows letters, numbers, punctuation marks, and spaces. And email assert verifies that the value in a field is a valid email address. To trigger validation and error handling, we need to add some code in the controller. So, let's do it. So, this is where we handle errors. First, we create an array of errors using a for each loop to iterate through the list of validation violations. We then use the implode method to concatenate the list of errors into a comma-separated string. Finally, we return a new response object with a 400 status code and an error string as the response body. Now let's check if our code works. First, we will send the valid data and make sure that everything works. And then we will corrupt the input data and check the behavior of our application. Okay, everything works as expected, and currently default messages are displayed, but they can be customized. Write in the comments if this point needs further explanation. And now let's finally set up the transport for synchronous message processing. As you can see, our microservice is now working through RabbitMQ. Messages are now processed asynchronously. So here's what we did. First, we registered the transport using the DSN in the .env.local file. Second, we went into the Messenger bundle configuration file, and in it we uncommented the line that defines the async transport. Then we defined the routing for messages that should be processed asynchronously. After messages have been routed, we consume them. And then we actually started sending emails and saw the asynchronous processing of messages in the RabbitMQ admin. And that's all for today. And we will devote the next video to testing this microservice. I hope you enjoy this video and see you next time.